Okay guys, so today we are talking about best fit lines or lines of best fit. So we talk about this when we have data that is on a graph, and we talk about correlation. So you guys know about positive correlation, negative correlation, and no correlation. So there's a way to use the calculator to determine just how linearly correlated is your data. How much is it forming a line? Okay, so you already have one of these in your journal that looks similar to this notes page, but it's not the same. Okay, it is pink, the one you already have in there, but this is a different one. You open it up and you see the steps are going to be a little bit different, but very, very similar to when we do stat edit and do option 4 linear regression. We're still going to do all of that, but there's one step we're going to do at the beginning. Okay, so at the top on this side we have all types of information about linear correlation. So we're going to talk about that in a minute and just how linearly correlated is our data. So we're going to try to figure out how we can take data such as this and we can look at it like this data right here. Maybe we could take this or this data and we could say, okay, well, what's the line that fits this data best? So you see, this is all different types of correlation. These, you should be able to look at them and say, those are definitely positive. This one, no, there's no correlation there, right? Those points are all over that graph. This one, and this one, that's negative correlation. You guys should probably look at that right off the bat and go, yep, that's negative. So we're going to talk about just how strongly correlated is your data. For instance, this one right here, this is a very strong correlation. Like these data points are basically forming a precise exact line. So we would say that's strong linear correlation. This one, well, this one we would say is actually, it's perfect linear correlation. This is a perfect line. This one is not perfect, but it does look like a line. This one, I mean, it's trying to form a line, I can tell. It doesn't look like no correlation, right? So just because your data points are not in a perfect line does not mean there's not linear correlation, okay? So we're going to talk about a way to decide if it is linear correlated and how strong it is using the calculator. The calculator is going to give us a value for that, okay? So here's our steps right here. Here's your calculator. It says the first thing you're going to do is select mode, okay? So you see the mode button right here, okay? You're going to need to push that mode button. Then you're going to want to scroll down. You're going to have to keep scrolling down quite a ways until you get to stat diagnostics. See that right there? It's going to be off. You're going to need to turn it on, okay? So the reason you need to go to mode and turn this on is because every time somebody resets the calculator, it turns this off. So if nobody's reset your calculator, it might be on. But if somebody's reset their calculator when they got it, it turns it off automatically. So when you take the STAR test, you're going to need to go in, remember to go to mode, hit the mode button, and you're going to have to scroll down until you get to stat diagnostics. It's right there. And you're going to want to make sure it is on. You're going to hit enter when you arrow over to on. Okay, so that's the first step. Select mode, and then arrow down to stat diagnostics and change it to on. Okay, so then we know we can hit second mode and it clears out our calculator screen. So now we're ready to do these steps we're familiar with. It says select stat and edit. Enter your X values in list 1, Y values in list 2. Then select stat, right arrow over to calculate. Select option 4, down arrow to calculate. All that should seem really, really familiar. That's the exact same steps that we've been doing to find linear regression or to let the calculator write the equation for us. So when we've been given a table of values, that's exactly what we've done. We've entered our X values in L1, Y values in list 2, and we let the calculator tell us the equation. We're still going to get that information. Okay, so let's do that now. Let's see what we get. So when you're given a table of values, remember X usually comes first. Y is going to be the second column. So let's go to Stat. Okay. And let's hit enter for edit. And let's put these values in list 1. All right. Then we're going to go over to list 2. Let's put our Y values in list 2. 15, 12, 8, and 7. Now look, I can already tell that my X values are going up and my Y values are going down. So remember, when we have values, one value goes up and the other value goes down, that usually means there's correlation. If you remember from yesterday, it should be negative correlation. So let's see. So we're going to go to Stat, back to Stat, the same steps we've been doing. Arrow over to Calculate, and we're going to calculate number 4, linear regression. Okay, we did put our X values in list 1. We put our Y values in list 2. We're going to go down to Calculate, hit enter, and you notice you're getting the same values here that you used to get. The A value, the B value, but now you have R squared and R. Now I'm going to go ahead and tell you this R squared, you don't even need to look at it. We're not going to pay attention to R squared. We don't care about that. We do care what this R value is. Now we've talked about this and we mentioned it yesterday. Remember on the worksheet we did yesterday on the front, I said don't do part B for 1, 2, and 3 with the graphs because that asks what the correlation coefficient is. Guess what R is? R is the correlation coefficient. This is how you find it. You have your data in a table, you do stat edit. As long as you've gone to mode first and turned on that stat diagnostics on, it gives you the R. So this is telling us our correlation coefficient is negative 0.9914208, all those numbers. So what does that mean? So for this right here, look up here, determining the strength of your best fit line. So it's telling us this is our equation right here. Our slope is negative 2.47. And so when you're doing this with data, you're going to just want to leave it as a decimal. When it's not a perfectly straight line, then you're going to want to just put in the whole table. Now, I know when we just were finding slope, before we've only been putting in like 2 values from the table or 2 rows, but this time you want to put the whole table in because that calculates your equation. It's going to be more accurate. The more rows you put in, the more accurate your equation is going to be because this data that we're calculating this line for looks something like this one, actually. It's very similar to this. So it's not a perfectly straight line. So we can't just do 2 points and calculate the slope. We need all the points possible because it's going to calculate the line that pretty much goes straight through the middle of these points is the one it's calculating for us. So that's this equation of this line right here. Okay, so our value is negative 0.991442. It's very, very close to 1, negative 1. So notice our notes say, and this means the absolute value of R. Now you should remember the absolute value means without negative or positive. So if we just look at the value without considering the sign, it's 0.99. So that means the absolute value of R, the absolute value of negative 0.99 is 0.99. So this one says if your R value, the absolute value of it, don't look at the negative or positive of it, just look at the value. If it's between 0 and 0.33, that's what we call weak. Very weakly correlated. Now that would be something like this one right here. See how these two are weak? They're not as strong as these. They're not quite forming a line, and they're definitely not perfect. So that's this. This is weak correlation. This is what our data looks like if it's weak. Okay? So moderate correlation is greater than 0.33 but less than 0.67. And strong are very, very, very strong. So if moderate, weak, and strong is going to be greater than 0.67, but it's going to be less than 1. If your correlation coefficient is 1, positive or negative 1, it is a perfect line, an absolute perfect line, okay? That would be something that looked like these two. Okay, so you can match up this table here, these values, with these correlations that I'm showing you here. And I'll put this picture on Google Classroom as well. Okay, so For our value here, the one we just calculated, we got 0.99. That is greater than 0.67. This is this is almost 1. This data here is very strongly linearly correlated. Now, it says, what is the equation for this line? Well, we have our slope and we have our y-intercept. So let's write our equation. It's y equals, our slope is negative 2.47, 2.48, I should round that, plus 2.48x, sorry, plus, what is, my calculator just went off. So what is our y-intercept? 26.6. We're going to round that one too. So again, when you're doing these line of best fits, you're going to have to round. You don't want to try and convert these to fractions. So negative 2.48x plus 26.6. There's our equation. What is the type of correlation? Is it positive? Is it negative? What is it? Well, what do you think this symbol right here means? Yeah, that means a negative. If the R is positive, it's positive correlation. If R is negative, it's negative correlation. So also look at your slope. Our slope is what? It's negative. So we know it's going to be a negative slope, so it's going to be negative correlation. What is the correlation coefficient? That's R. Our correlation coefficient is negative point. We're going to round it to like 0.99. We could do a couple more decimal places. 1, 4, 2. What do we say that? Chop it off there. 5 decimal places. What is the strength of the line? So that's when you go back up here and you say, well, we already said that this one's greater than 0.67 and less than 1. So this one is strong. Actually, it's very strong. Very strong. So using the best fit line equation, predict the value of the car in 10 years. Okay, so X was giving us the age of the car. Y was giving us the value. So they want us to predict the value of the car, and they've given us years. So notice years, age of the car goes in for X. So we have our equation here. We know the value of the car Y is going to equal negative 2.48 times 10 years plus 26.6. So the value of the car Y should equal, let's calculate this over here, negative 2.48 times 10, put that in the calculator, whoops, can't see that, plus 26.6. So what should the value of the car be in thousands in 10 years? Well, 1.8 thousands. Now think about that, 1.8 thousands. So it's not going to be very much. That's what happens to cars, right? They depreciate. As the car gets older, as age goes up, your value goes down. That's negative correlation. As one goes up, the other value goes down. So 1.8 thousands, that's really $1,800. Because this is in thousands. This is, if the car at age 1 is not worth $24. It's worth $24,000 because this is in thousands. So 1.8 thousands, if you're not sure about that, then you could multiply this to move your decimal point over by thousands. So, you would multiply by 1,000. I didn't say that. So it's 1.8. You could say that times 1,000 because 1.8 thousands, so times 1,000 would be $1,800, $1,800, right? Okay, so again, here's your correlations. So just because you don't have a perfectly straight line, your data doesn't make perfectly straight line, does not mean that the correlation does not exist. It is there. It can be weak correlation. You can have no correlation, but that's when your data's all over the place. It doesn't look like it's trying to form a line at all. Okay, so now you're going to tape this into your journal, your notes, and then you're going to work on this worksheet right here. So notice you're given a table of values. It's giving you a scenario, students weighting tables. So remember, when you have a table of values, they usually put your X values first and then your Y values. So you're going to put those in your table. You're going to follow these steps. Make sure you have your diagnostics on. And then you're going to write the equation that they give you with the slope and the y-intercept. And then it's asking you for the correlation coefficient. What is R? So is it positive, negative, and what is the value? So round it to maybe 3 or 4 decimal places. And then they're asking you a question. So this is what, just like we did down here, what's the value of the car in 10 years? Well, you're going to have a value that you're going to plug in, okay? So it's that same exact, like this example that we did down here. All right?